In this video, I introduce YOLO version 2 for better object detection. YOLOv2 improves YOLO object detector by making representation easier to learn without scaling up the network. YOLOv2 is further fine-tuned for classification on the 4480 by 4480 input image, which gives the network time to adjust its filter to work better on higher resolution input. And then the resulting network is fine-tuned for object detection. YOLOv2 employs the anchor boxes to predict the offset of bounding boxes instead of their coordinates directly, which increases the recall of positive bounding boxes. A classification head and object localization head are mounted on the top feature maps 13 by 13 generated by the laser convolution layer. The classifier predicts the class and objectness for each anchor box, while the regressor predicts the offset of bounding boxes. YOLOv2 finds the best prior dimensions of anchor boxes by running k-means clustering on the training set bounding boxes. The distance metric is defined as here. This is the k-means clustering on VOC 2007 and COCO. The elbow is at k is 5. Coordinates x, y of a bounding box can be computed by using parameters tx and ty, as shown here, where wa and ha are the width and height of an anchor box. xa and ya is the center of an anchor box, and tx, ty is prediction parameters. Defining tx, ty in this way, it jumps between +1 and -1. YOLOv2 predicts 5 anchor boxes at each anchor, and each anchor defines 5 parameters tx, ty, tw, th, and to. If cx and cy denotes the offset of a bounding center from the left top of the image, as shown here, the value of sigma tx and sigma ty are between 0 and 1, and pw and ph denotes the initial value of a bounding box. The prediction parameters of a bounding box are defined as here, which is easier to learn and makes the YOLOv2 model training more stable. The sum squared error is defined as a loss function. By substituting b into the loss function, we have the total loss, L YOLO, which consists of 4 terms. First, loss is for coordinates. Second, for dimensions of a bounding box. Third one, the LU, and the last one is for class probability. YOLOv2 takes 4 16 by 4 16 image as an input and performs predictions on feature maps 13 by 13, which combines the previous higher resolution 26 by 26 for multiple scale object detection. YOLOv2 allows to use different input resolutions from 320 by 320 to 608 by 608. The larger input resolution generates a higher classifier accuracy, but the latency becomes larger. YOLOv2 uses a darknet with 19 convolution layers and 5 max pooling layers as its backbone, where inception modules applied for higher computational efficiency. A pass-through layer further uses a 3 by 3 filter to double the number of channels from 250 to 512, as shown here. Then the output maps 26 by 26 are divided into 4 13 by 13 feature maps, as shown here. And finally, the output of the pass-through layer is concatenated with the feature maps 13 by 13 by 1024 in the regular path, as shown here. The resulting feature maps 13 by 13 by 2048 are converted into 13 by 13 by 40, as shown here, which is used as input to the output heads. This is architecture of a YOLO version 2 module, and this is the darknet 19 architecture for classification. For more details, please check with these references. Thank you. Bye.